Alright, so today we're going to look at section 7.6, which is on graphing exponential growth and decay models. Some needs you're going to want to have on you. Guided notes that I gave you, a calculator, and then a pen or a pencil. So I got a question for you. Would you rather have $10,000 given to you every day for the next 30 days? Or would you rather have a penny today, but I'll double it every day for the next 30 days? We were probably thinking, well, option A, a penny is not a whole lot. So let's start looking at these tables here. So after 10 days, I get $100,000. After 9 days, I get $512. So you're still saying, well, option A, Miss Marsh, it's got to be option A. Did you know that on option A, you will be making $300,000 at the end of the 30 days? Okay, that's how much your money you'll make. But option B, you will have at the end of the 30 days $1,071,824. $1 billion by giving you a penny every day for the next 30 days. And I'm going to double it. Bet you didn't amount that, right? Exponential growth. It's amazing how fast stuff can grow. And you see it every day. Bank accounts. If you have a savings account, that is exponential growth. It grows over time. Your interest grows. Population. You hear it all the time about how Bismarck's growing and expanding. Or uranium. That's how radiation, it declines. We see that all the time when they talk about Chernobyl and various places where we know that there's still radiation there, and over time it's going to decline. Your car, depreciation in your car, the number of years you drive it, it's worth less and less money. And then carbon fossils, carbon dating. That's how they know that a mummy is so many years old. They use exponential decay. That's how they know how old a mummy is. So this is very useful in real life situations. So here's some examples for you. Y equals 2 to the x. This is actually a growth function. Notice how as you go up, it looks like it's growing. Makes sense, right? So this is a growth function. Look at this one, how it looks like it's like sloping downwards. It looks like it's going like a slide. That is a decay graph. So it's an example of decay. This is an example of growth. Just to notice the nice slopes that you see on them. So an exponential model, what these is going to look like? They're going to look something like this. Y equals A times B to the x. An exponential growth function is when your B is greater than 1. So that's going to be this B right here is going to be greater than 1. That's known as your growth factor. If your B is less than 1 but greater than 0, a fraction pretty much, that is going to be a decay function, and your B is going to be known as your decay factor. So you're going to want to pay attention, look for that B. That's going to tell you, is your graph going to slope up or is it going to be going downwards? So let's actually graph some of these. So we have f of x equals 1 over 3 to the x. So f of x, remember, that's just a fancy way to write y. So we're going to have an xy tables for each of these. And you're going to plug in -2, -1, 0, 1, and 2. Easiest ways for you to be able to graph these things. So if you plug -2 in, you're going to do, on your calculator, 1 over 3 to the -2. I'll wait while you type that in here. That should be 9. You should have gotten 9. Did you? I hope you did. -1, you should have 1/3 to the -1. That's 3, so you're going to definitely need a calculator today. 1/3 to the 0 power. Notice I'm just taking the x I want, plugging it in. Anything to the 0 power is 1, so you shouldn't have needed a calculator. That's just 1. 1/3, excuse me, to the first, that is 0.33, so 0.33. And 1/3 to the second, that is 0.11. So you will get decimals when you're graphing these. So let's graph these points. -2, 9. -2, 9. There's an ordered pair right there. -1, 3 right there. 0, 1 right there. 1 and 0.33. That's just like right there, kind of. Doesn't need to be perfect, just a dot. 2 and 0.11, it's even closer to 0. So I'm going to connect my dots here. And it's just going to level out. If you would look at a graph and you keep pointing numbers, you would see it's never going to actually cross over 0. It's kind of cool that it doesn't. And in Algebra 2, you'll talk a little bit more about why it doesn't cross over 0. But for this, just for Algebra 1, we're just going to be graphing. So my graph, what kind of graph is this? Is it a growth or decay? If you look left or right, left to right, excuse me, you're going to see it's going downwards, right? Looks like a slide. So this is a decay graph, all right? Decay graph. What about this one? So just like last time, here's my x, here's my y. I'm going to plug in -2, -1, 0, 1, and 2. So we're going to do 3 times 2 to the -2. Now, don't multiply the 3 and the 2. Remember, PEMDAS. You got to take exponents first. So 2 to the -2 multiplied by 3. You should get 0.75. Please try that on a calculator. Make sure you type it in correctly, all right? If you do -1, you should get 1.5. 0, you should get 3. 1, you should get 6. And 2, you should get 12. Now, can't graph that point. That's fine. That's fine. That's okay. If that happens, that's fine. We'll just graph what we can graph. So -2, 0.75. So I have -2, 0.75. That's kind of close to 1, isn't it? So let's go right there. -1, 1.5. That's about right here, right? Between the 1 and the 2. 0, 3. Right there. 1, 6. All the way up to the top right there. And 2, 12. Now, I'm going to kind of graph it off graph right here. It's about right there, right? 2, 12. So now let's connect our dots here. So it's going to go straight, close, up, 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 and cross. There we go. Now, notice how they're never going to cross 0. Never should your graph cross 0, all right? You should never go to the negative y values. That's the way the exponential graph works. So let's just kind of classify here. Do you have a growth or do you have decay? So you're always going to want to look at your B here. Right here. You're going to want to ask yourself, is that bigger than 1 or less than 1? So 1.2, that's bigger than 1. So this is a growth graph. And you're going to look here. Is 0.3, is he smaller than 1 or bigger than 1? Smaller. So he's going to be a decay graph. 3/5, if you get that as a decimal, it's 0.6. That is smaller than 1. So this is decay. 7/2. Now, don't be like, well, that's a fraction. It's got to be decay. It actually isn't. 7 divided by 2, that's 3.5. That is definitely bigger than 1. So this is a growth graph. Be very careful. Make sure that you don't say fraction equals decay, because not necessarily. Check to see what that fraction actually equals as a decimal, so then you can figure out if it's bigger or less than 1. All right? Just be careful on that. And that's the end of this video. See you later, Sabers.